Hi there everybody, it's the whole universe, hope everything is fine, I'm a Rashman who brings all of experience, and today we're gonna dive into the AI and ML field. What is it? It is artificial intelligence and machine learning, and we're gonna talk about the different tasks, 4 tasks in this field. First of all, clustering, then classification, then dimensionality reduction, then regression analysis. What is it actually? Clustering, it is when we pick some data, we have data, yes, it is our inputs, we have data, some features of this data, for example, length, width, height, depth, colors, parameters, longitude, latitude, and other features that we have of the object. For example, I have the t-shirt and with a black color and also with not the super long sleeves. Wow, it's interesting. It is different types of features of this thing. And by the way, we have maybe kalimba, yes, and it is different types of frequencies that we have of this, and we have another instrument, for example, this clapping tool, or maybe it will be the kazoo, and different types of sounds and different types of features. And by these features we actually do clustering of different objects. For example, we have different types of guitars. Yes, we have 7-string guitar, or maybe 6-string guitar, or maybe double neck guitar, or triple neck guitar, and etc. Different types of them. Also ukuleles, and also banjos and mandolins, and different types of musical instruments. Also we have piano and organ, and also reed organ, pipe organ, and different types of organs. Also have xylophone, membranophones, different types of drums, yes, snare drum, and different types of drums. And we can actually classify them by listening only to them, but we actually couldn't know what's the name of this tool. Yes, we can see it is one harmonica. Yes, it is harmonica number 1. It is harmonica number 2. Yes, actually, it is almost the same instrument. Kind of sound almost the same, but a little bit changes we have inside of it. Actually, we can cluster them as one, or we can cluster them as different one. Yes, different ones that we have. And actually it all depends on our preciseness, on our accuracies that we'll take. Accuracy, it is when we measure kind of what's the most kind of, we can measure by this tape, yes, measuring tape, or maybe we can measure with this type of thing. Yes, it is different types of measures, and we can say in one situation that it is the one cluster, in another situation it is 2 different clusters, or we can say that it is one cluster, kind of 2 harmonicas, 2 different harmonicas, but with one, it is kalimba, and kalimba will be in another one. Yes, by the way, Nyan Cat is here. Okay, and if we will look at some pictures, we will see some patterns too, and we can say that this one is really like the pattern, and this one, it is another one. For example, we can look at this. Yes, it is our bow tie, and here it is. We have some colors here, yes, white, and other kind of black, and here's a little bit of brighter, yes, and we can say that it is one cluster, yes, and it is another, and actually in this another we have one more, kind of this one will be with a blue one, it is the first cluster, it will be with dark blue, it is second, and only whitish we have here, it is the third cluster. Yes, we can say it. And clustering actually works with unlabeled data. Unlabeled means that unsupervised learning. We have different types of learning in machine learning. It is supervised learning, semi-supervised learning, unsupervised learning, reinforcement learning. Actually, differences are with labeling the data, mostly, kind of, but actually in supervised, unsupervised, and semi-supervised, it is with labeling. Reinforcement, it is another one with competitiveness. And okay, we have clustering. Clustering, it is the task that is unsupervised. It means that we know nothing about the data, yes, and we need to pick them with specific features that this data has. Some clusters inside of it has some measurement similarities, yes, and feature similarities. It is achieved by using Euclidean distance, squared Euclidean distance, Mahalanobis distance, Minkowski's distance, Chebyshev distance, and other distances that we have in our life to measure some things. Cosine dissimilarities also have kind of with cosines from trigonometry. Yes, we we have sine, cosine, tangent, cotangent, secant, cosecant, arcsine, arccosine, arctangent, arcotangent, arcsecant, arcsecant, versine, vercosine, xsecant, xcosecant, different types of trigonometry functions. Okay, and it is our unsupervised learning task of clustering. Inside of the clustering, we have different types of algorithms. K-means plus plus, K-means sharp, C-means with fuzzy sets, fuzzy means... okay, I will name right now different types of algorithms, then I will say about fuzzy and things of this nature. Okay, also dbscan, hdbscan, GMM, Gaussian mixture models, dbscan, it is with density-based clustering, and also we have grid-based clustering and robust clustering. We have algorithms that are dealing with trimmed mean and Winsorizing mean and different types of means. It means average numbers with medians, with mode they work, k-modes, k-medians, also k-prototypes, different types of algorithms. We have Agnes, Diana, D-I-A-N-A, yes, it is with hierarchical divisive clustering, and also we have hierarchical agglomerative clustering, Agnes, yes, A-G-N-E-S, yes, it is different types of algorithms that we have. Actually, what's the difference between K-means and C-means? Fuzzy C-means works with fuzzy sets. Fuzzy sets means that one object could belong to two different clusters with some kind of weight to it. W-E-I-G-H-T, I think so, I pronounce it right. Okay, spelled it correct. Actually, we have different types of weights. Weights of objects. Weights means the power and the specific value that measures what this object will belong to. For example, to the cluster number 1 or cluster number 2. With to the cluster number 1 with the probability, kind of probability, we will not call this as probability with the number of value. It will be belonging of 0.75%, 0.75, yes, and to another cluster with 0.25. It means that 0.75 it is bigger than 0.25. It means that 75% kind of ish, it will belong to the cluster number 1. I hope that you understand it. It is fuzzy clustering, and K-means 1 or 0, kind of to this or to that, without some overlapping and without other kind of includeness to other clusters. Okay, it is the difference between fuzzy C-means and K-means clustering. Also, we have Agnes and Diana. Diana, it is divisive when we have the data, and then we dichotomize everything here, kind of, yes, ish. And also Agnes, it is when we do agglomerative nesting, kind of, we have data taxonomy here, and then we kind of include them and make it great again and make the biggest cluster ever, yes, by all the data objects that we have. Okay, it is about clustering. Clustering, it is one of the tasks. It is unsupervised learning. Also, we have classification. It is kind of almost the same as clustering, but it is a little bit different because it uses classifiers. Classifiers, it is the specific kind of machine, we can call it finite machine, finite state automata, yes, and we have the... and maybe not finite, but actually, okay, some automata and some of the machinery that could say that, okay, this tool that for example, we have it, yes, this tool. And it is actually, we know, it is the specific whiteboard marker, yes? What is it actually? And we have input of this whiteboard marker, object, and the system can say to us, is it a pen or a whiteboard marker? It is a pen. No. It is a whiteboard marker. Actually, the system says to us that it is maybe this one or that one. And with some probabilities, it means probabilistic. Probabilitylistic, it will be the classifier of probability, yes? And probabilitylistic classifier with some percentage. And with the percentage of 63, it will be the whiteboard marker. With 37%, it will be what? It will be the the pen. Okay, it means that 63 is bigger than 37. It means that it is a whiteboard marker. Okay, wow, classification is completed. It is a whiteboard marker. It is how it works. Actually, we have multivariate classifiers. It means we have different types of ways to classify the thing. For example, it could belong to the class number 1 or class number 2 or class number 3 or class number 4, or it could belong to class number 1 or class number 2. It is binary classifier. Binary means 2. Wow, Jesus Christ, it is an interesting word. Okay, and need to drink a little bit of water. It's actually classifiers. We have different types of classifiers too, and different types of algorithms. Actually, it all depends on the three or four we have, or maybe 2 different classes, or n number of classes, and etc. Okay, next it will be dimensionality reduction. As I said before, we have length, width, height, depth, RGB, RGBA, HSL, HCL, HSV, HSB, CMY, CMYK, model colors, color models, yes, model colors, color models, and also we have different types of parameters of our system, yes, weight, longitude, latitude, altitude, and different types of parameters that we could write by itself and by themselves, yes, and we have okay, these types of parameters, and we have dimensionality. Dimensionality means dimensions, yes, that we have. For example, we live in the 3D world, maybe. Yes, and if we will close one eye, it will be 2D actually. 2D that we can see the projection of something. Then it will be kind of 2 eyes, it means 2 different projections, and we see the world in kind of 3D-ish thing. Yes, and if we will increase the dimensionality, for example, we add some milliseconds, seconds, minutes, hours, days, weeks, months, years, decades, centuries, millennia, myriads, and etc. We add some time, then we will see that oh Jesus Christ, a lot of different things are happening around, and different types of dimensions we have, and it means that we have 20D, for example, or 40D space, yes, and we need to cut it, we need to reduce, we need to delete a little bit, and we need to get some, maybe from 20D we need 4D only. For example, we are talking about the paper. Yes, we have one moment. Where is it? Okay, I will have again. I will have this. We need to talk about a whiteboard, yes, today, and we have the parameters of this tool. Actually, we have the weight, yes, weight in terms of the kind of mass, yes, for example, but it is different, actually, weight and mass, it is different, because weight, it is more kind of the gravity thing, and mass, it is kind of inside, but okay, we have mass of this, we have also a position on X, Y, Z in the space, also we have the color of it, also we have maybe the belonging to the person, for example, it is mine marker, yes, not yours, yes, and maybe we don't need what this market belongs to whom, yes, we don't need the parameter of who is the owner of this marker, yes, we need to cut it, okay, it will be less, or maybe we need only the position of this marker, we don't need to know what is it actually, is it a marker or something, we need only the position of this object in the space, it means X, Y, Z, we need to find the center of the mass, and only the position of the center of the mass in the space of this object, and also maybe length, width, and height we need of it, and also maybe form of the cylinder, and that's all. Maybe we don't need some of the preferences and different types of properties that we could describe this thing, yes, and actually we do dimensionality reduction when we have 20D different features of this, and then we cut it to 7, for example, from 20 to 7. Yes, nice, actually. Good. Okay, it is kind of dimensionality reduction. Dimensionality means that we have different types of descriptions, and we need to cut it and make it less, make it smaller. Yes. Okay, next it is we talked already about clustering, classification, dimensionality reduction, and last but not least it is the regression analysis. Regression analysis, we have different types of them: linear regression, non-linear regression, polynomial regression, stepwise regression, and logistic regression, robust regression, rich regression, and different types of regressions. What is it? Actually, we have the empirical data that we got from somewhere. Yes, so we did the research and we got some data points, that we have data sets, yes, and we have some data in our life. And then we have this data, and then we kind of use the specific functions, the specific apparatus, the specific machinery tools, and then we can kind of do extrapolation of our function. Also, we can determine the target function, and also we can do interpolation of our function. It means that we have, for example, data, and we need to find the trend of this data. Yes, linear task. Also, we can use non-linear. Actually, it will be maybe this one. Also, polynomial. This one too could be. And actually, what's different between polynomial and non-linear? That non-linear, it is actually constructed by our linear, yes, and also it could be only with nominator and denominator, yes, and with things of this nature, with division, yes, with something divided on another thing, kind of equation divided to another equation, yes. And polynomial, it is with the polynomial patterns. It means to the x to the power of 7, for example, or x to the power of 5, yes, and different types of exponentiation of things that we have. Okay, it is polynomial, and also we have linear and non-linear, and also stepwise and robust and things of this nature. Actually, different types of them. Actually, what need to know about it, that we have the data and need to find the function. We need to find the specific graph. We need to find the specific plot of our things, and it is a kind of predictivity analysis, but actually we have different types of meaning to the predictivity analysis and regression analysis. Regression means that we are going backward, we do reverse engineering when we have the kind of data, and we need to find what is the law, what's the rule of this kind of data that it appears in our life. Okay. It is about different types of tasks that we have, about dimensionality reduction, about regression, about clustering and classification. Let me know in the comment section below what do you think about them, and did you know them, and did you understand what I was talking about, because it is the practice of English for Russian people who are ML engineers, maybe machine learning engineers, or maybe software developers, or maybe researchers in this field of AI and ML and artificial intelligence and machine learning. And let me know in the comment section below, did you understand, and what is the most interesting part that you heard, and maybe some new vocabulary that you find in this video. Let me know in the comment section below, and see you next time. You're a nice guy, oh boy. See ya, bye bye, improve daily.